Lastly, we have discussed about the closure property. In that closure property for the whole number, integers and the rational number, where we have performed different type of mathematical operations. Here we'll check for the another property, it's called commutativity in the whole number. So first of all we'll discuss that what is the meaning of commutativity. Commutativity that mean first we check for the addition. So commutativity that mean 0 plus 7 and 7 plus 0 both have same answer. So we can say that addition is a commutativity. Same for the subtraction. If I can write 3 minus 5 and 5 minus 3, if both have same answer, so I can say that these both are commutative. But 3 minus 5 it's become minus 2 and 5 minus 3 it's become 2. So these both have different answer. That means subtraction is not commutative. And same for the multiplication also. If I write 3 multiply 5 and 5 multiply by 3, so 5 3 is a 15 and here also 5 3 is a 15. That means these both are right. So we can say that it is a multiplication is commutative. So simply commutativity that means if I change the order of the question or sequence of the number, still its answer will be same. So we can say that that is an commutativity. This same property can check for the division. If I write 4 divided by 2 and 2 divided by 4, so both have different answer. So this is not then commutative. So same for the integer, we can perform the same task for the number of integers. So here also same like addition, subtraction, multiplication and division. So here also we can say that it is a commutative for the addition and multiplication but not for the subtraction and division. You can check that with the same operation as we have performed for the whole number. Then after third one is an rational number. Here also addition, subtraction, multiplication and division. It can apply for the addition and multiplication but not for the subtraction and division. So for the integer also addition and multiplication can perform the commutativity but not for the subtraction and division. Simply we can say that we cannot change the order of the question. Now we'll discuss the next property, associativity for the whole number. So in that, if we perform it for the addition, just like 2 plus 3 plus 4, and I make an association of the 3 and 4, so 2 plus this bracket, answer of this bracket will be 7. So 7 plus 2, 9. In another way, I can check that 2 plus 3 plus 4 and I make the association for the 2 and 3. So answer of this bracket is 5 plus 4, it become an 9. So both have same answer. That means we can say that it is an additive is an associative. Now for the subtraction. If we check for the subtraction, just like 2 minus 3 minus 4, and I make an association of the 3 and 4, so 2 minus, and answer of this bracket is minus 1, so its final answer will be 3. Same, if I change its associativity, 2 minus 3 minus 4, and change the association for the 2 and 3, so 2 minus 3 it's become minus 1, and minus 4 that means minus 5. So this both have a different answer. That means it is not associative. We can perform the same task for the multiplication. 2 into 3 into 4, and association for the 3 and 4, so 2 into, answer of this bracket is 12, and next if I change the association for the 2 and 3, so 3 to the 6 into 4, so it's also n 24. Both have the same answer. That means we can say that it is a associative for the multiplication also. Same for the division. We can check that same for the division also, and then after second was an integer. We can perform this above all tasks for the integers and the rational number also. So this every time we will find that addition, subtraction, multiplication and division. We will find that addition and subtraction will fulfill that condition, but subtraction and division cannot perform this operation, and there will be not an associative for the subtraction and division, and for the rational number also. Now another reason, the role of 0. Fourth one is role of 0, or we can say that additive identity also. Additive identity also we can say that. Here if we add 0 in any of the number, so there is no any types of effect on its answer, so we can say that it is a additive identity or role of 0. Then after fifth one is role of 1, or we can say that multiplicative identity. It shows that if I multiply 1 with the any of the number, its answer will be remain same. So it shows that multiplicative identity. Then after sixth one is additive inverse. Additive inverse that mean alternate or vice versa. If I write minus 3, so its additive inverse will be 3. If I write here 7, so its additive inverse will be minus 7. If I am question 63, so its additive inverse will be minus 36. Same as that means if we replace its the sign negative to the positive or positive to the negative, so we can say that it is an additive inverse. Then after reciprocal. Reciprocal, or we can say in another word, multiplicative inverse. Multiplicative inverse, that mean 38 into 5, so it's inverse reciprocal, or we can say the multiplicative inverse will be 5 upon 38. If I say 3 upon 2, so its inverse will be 2 upon 3. If I have 5 upon minus 7, so its reciprocal become minus 7 upon 5. Same way, we have to just change the numerator to the denominator and denominator to the numerator. So it become an additive, reciprocal, or the multiplicative inverse of that number. Next one, last one property is an distributivity, that means distribution of the number. So distributivity of the multiplication over addition. So how we can perform this means distribution of the 3 over 3 plus 4. That means 3 will get multiplied with the 3 and for the 4 also. That means 3 multiplied with the 3, it's become a 9, and plus 3 multiplied with the 4, so it's become 12. So its final answer is 21. So 3 has distributed over that bracket in the form of the multiplication over that addition. Let's take